Hi and welcome to this short video about acid and base calculations. You may ask, how can you summarize in just a few minutes all of the calculations? Well, yes. So what I would like to do today is show you the type of calculations that may come up in this paper one, and show you how, or hopefully help you identifying or giving you that starting point. Because I know sometimes when you read these big questions in exams, you're like, where do I start now? Okay, so my main tip is, well, first of all, don't worry yet about these equations, but what I want you to start noticing is what type of calculation is that. So there are different ones, and we can categorize them by looking at, the clue that we're given in the question, mostly given by the reagents that you're given in the question. So, for example, if you have hydrochloric acid and just that, think about what calculation could it be. So what I'm trying to say is that by reading the question, you can really identify the type of equation that we'll have to use, and hopefully that gives you the starting point. In fact, that there are I would say four type of calculation that you can come across. The first one we can see here on the left hand side, if it's a strong acid. So if it's a strong acid, you know that, well, pH is equal to the negative logarithm of H plus. As simple as that. The only thing to maybe keep in mind is, do you have a monoprotic, diprotic acid? So do you have, for example, HCl, or do you have H2SO4? This would make the difference because you look at the concentration of H plus, not of the undissociated acid. Okay, so think about it. What chemical do you have in the equation? Is it one that you're familiar with, that is a strong acid? Then it's likely to be a strong acid calculation, likely to come up in those multiple choices or just a few marks. Okay. What if you have this reaction? Can you guess which type of reaction is? It's a neutralization. It's an acid and a base. This type of question, you would clearly understand that it's a neutralization reaction because in the description of the question, there would be an acid and a base reacting together, and you would be asked to find the pH of the remaining solution. Okay, in that case, you need to think about first, from your basic knowledge of chemical reactions, we have reactants react together. But if you have amounts of both reactants and products, this means that there will be something in excess. Okay, so if there is something in excess, and I'm going to put the link to the video of this calculation, but if you have something in excess, then you may have an acid in excess or a base. If it's a strong acid calculation. If a base it's in excess, or if you have to find the pH of the base, you would use this equation. So you know that it must be this equation because it's the only one where there is the OH as the ion. And this is the one without the pH, in the sense that you could also use the logarithm version of this equation, which is pKw is equal to the pH plus the pOH. However, bear in mind that the pKw, it's 14 only at 25 degrees. So it is a different value at different temperatures. So you can just use this equation, and you can always derive it, because know that dissociation of water is what results in the presence of the other ions, so OH minus and H plus, which means that an equilibrium sets up. Equilibrium is just H plus and OH minus concentration, because this is 2 in excess, so it's negligible. And then you need to find the concentration of H plus, because at the end you always want to get to the pH, so negative logarithm of H plus. So this is the rearrangement, and this would be for a strong base. And you either have straight the question about pH of a base solution, or one of these neutralization reaction if the base is in excess. Okay. And this one that seems so long and so many letters, it's a weak acid calculation. You know straight away that this is going to be the one, because you would be given a Ka value. So if you are not too sure, but if you have a Ka value given in the question, well, write down the Ka equation. So it could be, normally you would have it of organic acid, ethanoic acid, propanoic acid. You would be given the Ka value, so you know that it's likely to be a weak acid equation. So I would always suggest, if you're missing that starting point, just write the Ka equation down, because this then will help you, carrying along the exercise. And if then you write this down and you notice that there is nothing else present, it's just a weak acid, and you would understand that by looking at the question that you only, it's mentioned only that weak acid chemical, yeah, only like propanoic acid, blah, 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 blah. That is it. You don't have a base, you don't have a salt, nothing. Then you know that is the equation. Bear in mind the assumptions that are made. The assumptions that are made are that the H plus that comes from the ionization of water is it's not doesn't change the concentration from the acid. That's one assumption. So that the H plus from the ionization of water is negligible, and that the HA concentration, which as you can see, you have it. So the initial acid concentration in this equilibrium constant value, the initial concentration, so the initial concentration is equal to the concentration at equilibrium. So two assumptions that are made. And then because this assumption is made, you know that this is the rearrangement to do H plus to the power of 2, and then HA, because you know that at the end you want to find the H plus to get the pH. So weak acid calculation is the one to do if you are given the Ka value, and if in the description you have just the weak acid to calculate. So nothing else is reacting with it, or if the weak acid is in excess. So that's always something to understand from the question. Okay. The last one is this one. One thing, notice that is different from the one before just because of this. We still have a weak acid, but you would have a hint in the question that there is some kind of base or a salt that is present. In fact, the difference between weak acid and the buffer calculation is that the conjugate base of this acid comes from the salt. So we cannot make that assumption that H plus and A minus are the same, which means that this in the same Ka, so Ka should be your starting point of this weak acid or even buffer calculations, and then you can make this analysis. Can I do the assumptions that H plus and A minus are the same or not? Well, if you're given a salt concentration, then you can't make that assumption. In fact, this would be the conjugate base, so the arrangement is slightly different, and H plus would be rearranged like this, and then again we have the pH. There is also the Anderson-Hasselbalch equation that can be used, but if you're not too confident about pKa's or so on, don't worry about that too much. I'd rather that you try follow with logic. Okay, so what I would like you to try is when you do practice questions, before you even start an acid-base calculation, think about this. Like, okay, from the understanding of the question, which calculation do I have to do? Or which calculation, which equation should I use? Strong acid, strong base, weak acid, or buffers? And this is the summary. Okay, so check out more videos for calculations, for example, of calculations for titration curves and so on. But here I wanted to show you that hopefully by being confident with the equations, you can also apply them better in the exams. Good luck.